All right, so this lesson is going to be on 8.5, and we have, they call it random variables, probability distributions, and expected value. Really, expected value is our big idea. So if you look at this idea you have in front of you here, let me grab it. Hold on. Oop. It's talking E of X, expected value. So think about if you're going to go gamble, right? And you're going to play some hand, what is your expected value? Okay, that's important to kind of think about. Also, what if you're going to run an insurance company and you know people are going to hit deer? We're in Wyoming for car insurance, and so you need an expected value in order to be able to figure out how much money you're going to be paying out so you can make money and break even. Or we don't want to break even, we want to make money, right? So the idea is you take the amount of money times the probability plus same thing all the way down and add them all up. So we could have something like this one, and it says, is the probability distribution for the random variable in a given table? If the probability distribution is given. Okay, so this problem wants to know, first of all, is this a probability distribution? So expected value is timesing things together, but distribution, they better add to 1. You have every case taken care of, okay? So they have a -2, a 0, a 2, or a 4. Maybe you pay in $2 for this raffle and you could win nothing. You could win $2 or you could win $4. Pretty basic. That's what that's kind of looking at. So if I want to know if this is an actual probability distribution, these have to add to 1. So plus 0.3 plus 0.2 plus 0.4 plus 0.1 does equal 1. So does it add to 1 is a question, right? Then it is a probability distribution. Okay, it has to be a full distribution to find the expected value. So the expected value is timesing each of these together. I will write it out on this first one. So the expected value will be -2 times the probability of that -2 plus the second one, 0 times the probability of 0.2 plus $2 times the probability of 0.4 plus 4 times the 0.1. Got an extra decimal in there. So let's put that in our calculator. So -2 times 0.3 gave me -0.6. And then that one 0 plus 2 times 0.4 is going to give me 0.8 plus 4 times 0.1 is 0.4. And let's see what those add up to. -0.6 plus 8 plus 0.4 is 0.6. So our expected value is 0.6. And again, we can only do that if it actually is a probability distribution. So it has to be the full distribution. So you just times, add them up. You could also call this the mean. Those of you that have taken statistics, this is the mean of your probability distribution. All right, next one. So 0.1 plus 0.4 plus 0.1 plus 0.4. Ooh, that does add to 1. Okay, so it adds to 1. So we say yay, right? Good, it adds to 1. Look at my 1. I think that looks a little trashy. There we go. So how would we do the probability of this one? We just still times down. It's going to be the same values on the top as we had up here, right? Same values. Thinking of us pay in $2, get out 0, get out 2, get out 4. What are those probabilities? Or who knows what this is in a distribution of? It could be anything. So if we go to do that expected value, again, it's going to be -2 times 0.1 plus 0 times 0.4 plus 2 times 0.1 plus 4 times 0.4. So put that in our calculator. I thought I had a better calculator. Here's my better calculator. Oh, it's just easier to see. I like it. Okay, so -2 times 0.1 plus 0 plus 2 times 0.1 plus 4 times 0.4. I got 1.6. All right. Hopefully I plugged her in right. So that's it for our expected value. All right, the following table gives the probability distribution, so we already know it adds to 1, of the number of packages in thousands handled by a shipping company. Find the expected number of packages handled on one day. So hopefully these word problems bring in why you're doing this in business, right? You really have to understand probability of like how many items are going to be in your distribution center, right? So you can figure out how much space you need and things like that. So our expected value, right, will be just timesing straight down. So 4 times 0.3 is going to give me 1.2 plus 8 times 0.05 is 0.4. 12 times 0.1 is 1.2. 16 times 0.3 is 4.8. 20 times 0.25 is 5. Okay, so 1.2 plus 0.4 plus 1.2 plus 4.8 plus 5 is 12.6. So we will have 12.6 thousand packages handled every single day in this by the shipping company. Okay. All right, next one. You draw and you keep a single coin from a bowl that contains 21 pennies, 14 dimes, and 15 quarters. What is the expected value of the game to you? The expected value of the game to you. So we're going to draw a single coin from a bowl. All right, how many total coins do we have? 21 plus 14 plus 15. So I have 50 total coins. And what I'm going to want to do is figure out, hang on just a sec. Hold on just a sec. Okay, so if you want, you first always want to start with your probability distribution. When I reach in, I'm only getting out one coin. So what is our first coin that we could get out is a penny, right? So I'm going to do a little chart here of our X values, right? And our probabilities. So our first one could be 1 cent. And we want to write it in terms of money. So when we do our expected value, it's money. We don't put 1, we put 0.01. So what was our probability of that? Well, we added them all up and there were 50 total. So 21 divided by 50 is going to give us our probability of 0.42 here. So there were 21 out of 50 of that one specifically. Now the next one, let's see, the probability of a dime. So a dime is 10 cents, right? So it's like this. And there were 14 out of 50. So that's a probability of 0.28. And the last one is you could get a quarter, which is 25 cents. And there were 15 out of 50, so 0.3. And then now to do our expected value, we're going to times these together, right? So our expected value is going to be 0.01 times 0.42. And then we're going to add that to 0.1 times 0.28 plus 0.25 times 0.3. I got let me see what I did wrong. I did not get the right answer. Hang on, when I put it in my calculator. 0.01 times 0.42, 0.1 times 0.28 plus 0.25 times 3. No, I got 0.5822. 0.25. It's not. I don't know. Okay, maybe I put that in wrong. Sorry if I did. I don't see anything wrong with mine. That's why I went to the bigger calculator. They got 0.107. So maybe I did something little wrong. I'm just going to type it in again. Either way, we know that it doesn't matter. I'm not going to worry about it. So can you set it up and get it right? Either the answer is 0.10, which makes way more. Yeah, we can't get 58 cents. Let me do it again. I'm like, we can't get that. 1 cent times 0.42. That's going to give me 0.0042. 10 cents times 0.28 is going to give me 0.028. And then quarter times 0.3 is 0.075. All right, add those up. There's no way that could be our answer. It has to be lower than 25 cents. 0.0042 plus 0.028 plus 0.075 is, yeah, 0.10. Yeah, it's what they had, 0.1072 is what the answer is. Okay, now I match. That makes more sense. I was like, wait, we do have way more of a probability of getting 1 cent, but our expected value is about 10 cents or 11 cents if you round to a nearest cent. Okay. All right. So the next one asked about flipping an unfair coin. So we're going to toss this coin. If it's heads turns up, you win $1. If tails turns up, you lose $1. What's the probability? Okay, so let's do our little chart again. This is always where you want to start. Every single condition has to be taken care of. So if you flip a heads, you win. Well, let me label that a little different. The heads needs to be up, like it's a heads up here, right? What do you win if you get a heads? You win $1, right? If it's a tail, you lose $1. So you got to write that as negative. And the probability of a head is 0.39 because we do not have a fair coin, and 0.61. Okay, so because our coin isn't fair, right? So 0.39 for our expected value times 1 is 0.39, and then add that to 1 times 0.61, and I got negative 0.22. So we are going to be in the hole, and we're going to be in the hole 22 cents. Okay. All right. So that's one like that. Okay. A 5-card hand is dealt from a 52 deck of cards, right? A 5-card hand. If the 5-card hand contains at least 1 7, you win $10. If it contains at least 1 7, you win 10, otherwise you lose $1. So this one, let's do some probability stuff. We know we have 2 things with our chart, right? Here's our X, here's our P. I'm writing this small because I need space. You either win $10 or you lose $1, right? That's our 2 things. Now we have to find those probabilities, and that's not that easy. We have to look at our first hand, and you have to think about at least. Well, the probability of at least 1, you have to get the probability of no 7 on all of our hands, the probability of none. Then you have to minus it from 1. So you anything at least, you have to do the opposite. So maybe use no 7. So on our first hand, what's the probability of not getting a 7? Well, there's 4 7, so there's 48 left cards, right? So the first hand, you have 48 out of 52 of getting no 7. Your second hand, right? Or second hand, I keep saying hand. Your second card, not hand. It's all one hand. But the second one, you have a 47 out of 51, because now one card is dealt, right? So 1 less of each all the way down. So the third one would then be 46 out of 50. And the fourth one would then be 45 out of 49. And the fifth one will now be 44 out of 48. Did I go down right? 44. Okay, so then what we'll do is the probability of none, we will then count down, or okay, so we're gonna have to do this probability of none. No 7 is gonna be each of these times together because you have to get all 5 of these in one. So it'd be 48 out of 52 times 47 out of 51 times 46 out of 50. I felt like I didn't count down right, but I did. 45 out of 49 times 44 out of 48. So I got to put that in my calculator. 48 divided by 52. Sorry, I didn't pre-do this one, so I don't know the answer to cheat. I stole it from your homework, but 46 divided by 50 times 45 divided by 49 times 44 divided by 48. Okay, I got 0.6588-ish. So we have to do 1 minus the 0.6588-ish to get the probability of no, and this is money, right? This is at least, sorry, at least 1/7. I can't write that there. At least 1/7. Gosh, I still can't write that. Tried to write 1/7. Oh well. So 1 minus 1 from that, I got 0.34. Let's just go 2 decimals. So the probability is 0.34 that you got at least 1/7. So the probability of none would be the 0.65. Let's do 0.66. Just go in 1 decimal, right? And the 0.34 plus the 0.66 does add to a 1 because we need it to, right? So this was 0.34 over here. All right, so we're going to times this. We get $10 at the 34 probability. So that's going to be 3.4 plus the -1 times 0.66 is -0.66. So 3.4 minus 0.66. So if you play this game, your expected value is $2.74. So who's winning more? Definitely play this game because you're way more likely to win, not the people at the casino or wherever. They are expected to lose and have to pay out. So as a casino, right, they always have negative expected values. Never are they going to have positive. They can't. They aren't going to be that big and beautiful if you're winning millions every time you walk in the door, or even hundreds. No, not going to happen. Okay, so we did our $10 for the 1 out of 7. All right. So the next question is for decision making. After careful testing and analysis, an oil company is considering drilling at 2 different sites. It is estimated site. Okay, I had to choke for a second. An oil company is considering drilling at 2 sites. It's estimated at site A, they will net 50 million if successful at a 0.2 probability and lose 3.5 million if not. Okay, so successful, not successful. Site B, it's 70 million at this probability. So let's look at site A. And we'll do in our probability distribution, right? So 50 million we could win, or we could lose 3.5 million, right? So we have to invest. Either we're going to win money or we're going to lose money. So it's probability of 0.2. That's terrible. That we win 50 million. And there's a probability of 0.8 that we lose. So times this together, right, for a probability. So 50 times 0.2 plus negative 3.5 times 0.8. I got not the right answer. Hold on. $7.2 million. So we are estimated to make about 7.2. So let's look at site B, same idea. But on that one, they said 70 million with a 0.1 and negative 5.5 at a 0.9. Okay, so 70 times 0.1, and then we're going to minus 5.5 times 0.9, and I get an estimated value on this one at 2.05 million. So you're way more likely to get oil and make money off of site A because you had a higher expected value overall. All right, that's what I got for this section.